everyone, today I am going to present about Newton-Raphson Method, which we use tangent line to approximately find the roots of the solution. So the important part of Newton-Raphson Method is the formula, which is, we look here, is xn plus 1 equal to xn minus the function when we substitute the x over the derivative function. Okay, so when we look at the equation here, we get fx equal to x power of 3 plus 2x squared plus 3. And we also have to find the derivative for the function with using a calculator, or you can just calculate it by yourself, which is 3x power of 2 plus 4x. So I will be explaining about the table. So here, n here in the table is iteration. Xn is the x value. The first iteration is the first x value that we have to guess. It's the only x value that we have to guess. The previous x is we got from the calculated from the formula. So the fx here is we simply just substitute the x that we guess into the formula that are given, which is here is x power of 3 plus 2x squared plus 3. So same goes as the derivative of the function. We just simply substitute the value of x. So the first iteration we do not have any error, since error is measured by absolute value of the current x value, x value of the iteration minus the previous x error. So you might not getting what I am saying right now, so I will be explaining about it later. So for the second iteration, the x, how I calculate the x is by using the formula that are given for the Newton-Raphson method. So it is just 1 minus with 6, which is the function of 1, and over with the 7, which is the derivative of the function. So same goes as the fx, we just substitute the value of x into the function. Same goes, we just substitute the value of the second x iteration, and we get 3.04. Same goes as the derivative, we sub the value of x, and we get the value. So for the error is what I just mentioned just now, which is the absolute value of the current x iteration, which is here is 0.142857, and minus it with 1, the one that we have guessed earlier. So that is how we can calculate the error. So the error that we get here is 0.857. The less, which is the more zero that get, meaning that if it's like 0.00, meaning that you are reaching your root, which is more accurate. So we have to keep on going until the error have more zero value, means that it has a lesser error. So meaning that we are approximately reaching to the roots. So what I'm just doing here is I just drag the formula until the bottom. So for all of the iteration, so that I can know which one has more zero, so that I can know which one have lesser error. So here I chose 8 iteration as my roots. 8 iteration, which is negative 2.48559 as my roots, because it has more zero there, which means we have less error. So